This is Mr. Anderson for Kellogg Community College, and this is part 2 of my video to explain the basics of regression. And regression is going to look at the relationship between x and y. Is there a positive relationship between x and y? Is there a negative relationship? Or is the relationship so weak that it's not significant? Our values tell you these things, and we're going to do a t-test and an r-test to show you the difference between the two of them. I am using a book where the tables have names to them. For example, table F is the T table, and table I is the R table. I may interchange, I may say T tables and R tables, and I may interchange with the name of the book table, but if you have your book with you, or if you have a formula sheet that you got from the internet, you could use those. So the first step that we're going to do is we're going to look at the null and the alternative hypothesis. The null hypothesis is to say that there's no correlation, and we would indicate that with rho, that's Greek letter RHO, is equal to 0, because if the R value is equal to 0, then you have no correlation. So the null hypothesis is that, hey, there's no correlation. But if rho is not equal to 0, then there is a correlation. And these are always two-tailed problems, because R can be either a positive or negative number between -1 and 1. So this is the null and the alternative hypothesis, and now step 2 is going to be to find the critical value. The critical value is going to be found on table F, which is our T table for this problem. And we have to know the number of data points we have, and we have 6 data points. The X value represents the number of tens of thousands of cars, so this would be 63 tens of thousands of cars, or 630,000 cars. And this would be 7 in billions, the amount of revenue is made, so 7 billion. I know you might think just, get more cars, make more money, but revenue is different than profit. Profit is how much you make after taking care of all of that. So I'm sure there's definitely a breaking point where too many cars means it'll dig into your revenue. So let's actually go further and get our critical value now that we've talked about why we're using the T table, because there's only 6 data points here. We're going to look at our degrees of freedom. This is another reminder that degrees of freedom is going to be n minus 2. So 6 minus 2 is equal to 4. This is true because we have an x and a y to deal with rather than some of our single variable equations. So now that we are going to also look at our critical value with 4 degrees of freedom at that spot with an alpha of 5%. And I know there wasn't an alpha given in this problem, but in the case of that, as we've seen in homework problems before this, anytime alpha is not given, let's default to 95% confidence. Our critical value is going to be plus or minus the 2.776. It is true that the table does not give you the plus or minus, so you always, when using a t-table, have to either put the plus, the minus, or the plus or minus on, depending on the number of tails in the problem. Now in step 3, the formula is going to be t equals, and this is r, the r value, times the square root of n minus 2 divided by 1 minus r squared. Now we got the r value from using the regression equation, and we've done this on the calculator, and we found that the r value for this problem is 0.98. Very strong correlation. Then we multiply the 0.98 times the 6 minus 2 under the radical divided by 1 minus parentheses 0.98 parentheses squared. I highly recommend you use these parentheses, because if you don't, when you have negative r values, it tends to get the problem wrong. So what I have here is 4 and then minus this divided by this denominator, take the square root and multiply by 0.98. You get your t value, and your t value is 9.85, which is really, really far away from the norm. So in step 4, when you draw your normal curve, where 0 is in the middle, you have a critical value at plus or minus 2.776. So at this value of 2.776, you see that we are going to be well beyond that, because this correlation is so strong. The correlation is going to be way over here at 9.85. And so in your conclusion, since 9.85 is much greater than 2.776, and much doesn't really matter, it just needs to be bigger than 2.776, we will reject the null hypothesis. And we're rejecting the null hypothesis because the null hypothesis is saying there's no correlation. But there's a very strong correlation. 0.98, that R value that we got on the previous video, that R value is incredibly powerful in swaying this towards the idea that there is definitely a correlation here. Now let's compare and contrast this versus the R test. In the R test, the null and the alternative is the only thing that actually stays the same. The null and alternative will basically be rho is not equal to 0 and rho is equal to 0 and rho is not equal to 0. Now what you do in step 2 is you find your critical value on table I. This is also known as an R table. Now there obviously is a column for looking up your alpha, so you look up your alpha on table I. For the degrees of freedom, in this case it would be 4 degrees of freedom, so df equals 4. So 4 degrees of freedom with a sample size of 6. And sometimes if you look at different tables, some tables won't have degrees of freedoms, some tables will just have sample size, but either way you get a value of plus or minus 0.811. So this is telling me if you have a R value that is greater than 0.811 or 81% or less than negative 0.81, then we will have to reject the null hypothesis. So step 3 is to get your R value, and we did that on the previous page, which was 0.98. For step 4, instead of drawing a normal curve, I like to draw a number line from -1 to 1, because this then shows you the two zones or critical regions here. And this critical region is at 81%, and this is at -81%. And we use the -81% loosely because we like to think about how close it is to a perfect negative correlation. But this 1 to -1 should be just seen as, 0 is no correlation, 1 is a perfect correlation, and there's your low and high. So for step 5, we look to see where 0.98 was. 0.98 was that flag right there, almost close if not touching the 1 basically. So since the 0.811 is less than 0.98, we will reject the null hypothesis. So just like on the left hand side over here, the null hypothesis is rejected by getting into the shaded section. So we will reject the null hypothesis. And remember, the null hypothesis, its statement was saying like there's no correlation between buying cars and getting revenue, and we can definitely see that's false. Now, of course, as I said before, revenue doesn't equal profit, so please make sure that you just don't buy all the cars in the world and expect unlimited amounts of money to roll in. This is revenue, and revenue is not profit. So thank you for looking at this example, and that finishes the 2 parts of this introduction to regression video. And please, if you haven't seen the first one, go back and get it, because that will discuss in great detail scatter plots and all the other parts of the R value. Alright, thank you very much for watching.